All right, so we're going to learn about polyatomic anions, or polyatomic ions in general, because they're not all anions, but polyatomic ions. All right, so we haven't really covered molecular compounds just yet. We sort of briefly mentioned them, but essentially, sometimes, and this will make more sense when we actually do get into molecular compounds, but sometimes a molecular compound ends up with a charge. And I'm going to give a quick example. So when we continue on with this a little bit later, or if you kind of already have a grasp of this, it'll make sense as to why this is true. So here's an example of, thank you, one polyatomic ion that we may run into. Okay, notice it consists of an oxygen and a hydrogen bonded together, and they have an overall charge. So this thing is an overall charge. Now, how does that happen? Well, it happens like this. We know from experience that oxygen has 6 electrons in its outer shell. Okay? We also know that hydrogen has 1 in its outer shell. Okay? So if these two combine together, what will end up happening is you'll get something like this. Now the problem is, you can't make a bond like this because oxygen's outer shell will not be full, and hydrogen's outer shell will not be full. So the way to make this into a viable compound is you need to bring an outside electron into here, okay? Now, if I bring an electron from outside that wasn't there before, there's going to be more electrons than there were original protons. And what that results in is this guy up here. We form that bond, that extra electron that wasn't there before leaves this whole molecule with a charge, okay? And that's a polyatomic ion, okay? That's why they exist, all right? You do not have to memorize these, but just be aware that there are many, many common polyatomic ions. In fact, you have a chart of them, okay? Now, hang on one sec, and I'm going to grab a chart and throw it in here. So you can find tables like this scattered around on the internet, and what they show you is a lot of the common polyatomic ions that are out there, okay? And some of them are fairly complicated, but essentially they work in the exact same way that any other ion with that particular charge would work. So let's do a couple of examples with some stuff that we pick off this list. So let's find one. How about this one here? Chromate. So there's a polyatomic ion called chromate that looks like that. Okay? Can you understand why they're called polyatomic ions? Do you know what the word poly means? It means more than one, right? Multiple, right? So it's multiple atoms, but together they make an ion. Okay? So this guy has the name chromate. All right? So let's imagine that we're making chromate and we're combining with a few different things. So the first thing we'll combine chromate with is sodium. Okay? Well, sodium has a charge of plus, so that must mean we need 2 of them to go with a chromate. So how are we going to write that? Well, we'll write Na, we need 2 of them, and CrO4. If I just saw this, I might not immediately think, hey, that looks like an ionic compound. But how I would know it's ionic is the fact that it has a metal first. The second you see a metal as the first part of this, you immediately know that's an ionic compound, at least for our purposes. Really, or for any purposes that I'm aware of, actually. Okay? And then the next question is, how would I name something like this? How do you think I would name it? Sodium chromate. Just that simple. Okay? Now let's imagine that we take chromate and we want to combine it with this. What's that ion called? Lead what? Excellent. Lead 4. That's a lead 4 ion. Or if you're old school, that's the Plumbeck one. Okay? So if I want to do lead 4 with chromate, how many chromates do I need to go with the lead 4? I need 2 chromates. So this is where something new comes in. So I go PB, then I go chromate, but how many chromates do I need? I need 2. So if I just put a 2 here, it's confusing, isn't it? I see a 4 and then a 2. So move that up a little. So what I have to do is I have to throw this into brackets and then say there's 2 of everything within the brackets. So it's like math class, right? This applies to what's in the brackets. So this would be, if we wrote out the name, lead 4 chromate. Okay? So if we look at this list, I don't expect you guys to memorize the list. Okay, that's crazy. There's too much. Okay? Something that you'll notice though is what element do like most of these contain in it? What element do you see repeated over and over again in a lot of these? Oxygen, right. So a lot of these have oxygen involved in them. There's a good chemical reason for that, a little bit beyond where we need to go with this course, but that's definitely something I want you to keep in mind. And then I want you to notice that for the most part, these guys end in 8, okay? 8, or some are ite, okay? Things that end in 8 or ite indicate polyatomic ions. When they weren't polyatomic, they end in ide, right? Chloride, sulfide. If they're polyatomic, they end in 8, okay? There's one more thing I want to point out. Oh, right. And that's how do I know if it's nitrite or nitrate, or aterite, I should say. And for an example, I'll use, I want to use chlorate. Yes. Okay, so let's take a look at this. ClO minus, ClO2 minus, ClO3 minus, and this also exists here, ClO4 minus. All of these things exist. We can see them right, where are they? Where did I just see them? Right here on the periodic table, or right here on this table of common ions. So if you look, we have chlorate, chlorite, hypochlorite, and perchlorate. Now how those are named is like this. The one with less oxygens in it is the ite. Okay, so this is chlorite. This has more, it's chlorate. Okay, this has more than chlorate, so it's hyper. Is that right? Did I say that right? I think I did. Sorry, I didn't say that right. My bad. Let me fix that. It's perchlorate. My mistake. Perchlorate. And then less than chloride is hypochlorite. Okay, so there's some logic into how the polyatomic ions get their names. As far as you're concerned, you just have to be able to look them up on the chart and work with them at a basic level. Okay. So let's try a little challenge here. Can you write for me magnesium perchlorate? And you know that's not going to be a chloride because it says 8, right? Can you take a minute and write out what you think that would look like? Okay, so some people seem to be struggling with this a little bit. Sorry? Yes, it would. So how we do this is we look at magnesium, which you know from your work on the periodic table is this. So just finishing up here, you know from the periodic table that magnesium has a 2+ charge. Perchlorate, you got to go look it up if you don't already know, but it has a negative charge, so we need 2 of them. We need 2 of these guys to go with magnesium. So the way to write that, magnesium, bracket, ClO4, and we need 2 of them. Magnesium perchlorate. Okay, when we get back on Monday, we're going to do some work on that.